Y en este primer bloque vamos a tener 3 presentaciones. Vamos a tener primero la presentación de Matt Upston sobre el procesamiento del lenguaje natural en la industria. Esta es una presentación que se va a hacer en inglés. Ustedes en la aplicación de Slido pueden hacer las preguntas en inglés o en español y nosotros hacemos la traducción si es necesario. Luego vamos a tener la presentación de Wolfgang Schmeisser, que va a presentar sobre detección y clasificación de estereotipos contra la inmigración surgidos de fake news en redes sociales. Luego vamos a tener la presentación de Javiera Lobos sobre cómo incursionar en las aplicaciones de procesamiento de lenguaje natural dentro de la industria. Y una vez que expongan las 3 personas, vamos a abrir el espacio para las preguntas. Y entonces recuerden que todas las preguntas las podemos centralizar a través de la aplicación de Slide. Entonces creo que ya estamos en el momento de dar paso a nuestro primer invitado para esta sesión. Nuestro primer invitado es Matt Upston. Él viene del área de las ciencias medioambientales, hizo un doctorado y el año 2015 decidió dejar la academia y desde entonces ha trabajado como data scientist en distintas áreas del gobierno del Reino Unido, en startups y también en organizaciones no gubernamentales. Y actualmente es el fundador de una empresa que se llama Mantis NLP, que se dedica a hacer aplicaciones y investigación, o sea, como implementaciones de procesamiento de lenguaje natural para distintas áreas. Así que, Matthew, muchas gracias por estar hoy con nosotros. Yo voy a dejar de compartir la pantalla.
Muy bien, gracias Rida, gracias por presentarme. Lo siento mucho, voy a hablar en inglés. Espero que no les importa mucho, pero estoy mucho más cómodo en inglés. Thank you. So thank you, Riva. Thanks for the introduction. I'll start sharing my screen right now. So, as Riva mentioned, so my name is Matthew Upston. I'm the founder of this company, Mantis NLP, which, as Riva said, is focused on natural language processing in industry. And this presentation really is about sort of my experiences of working in natural language processing, having finished a PhD, which was not related to natural language processing. And then the steps that kind of took me towards starting a company with a colleague of mine. And then finally, probably the most interesting bit, what we're seeing in the industry and how things are changing most recently. So I've drawn you a little diagram to show you my kind of journey through from academia into founding a company. And I'm going to talk about sort of 3 distinct phases, which is basically this sort of phase here between, for me, 2015 and 2018, when I worked mostly in the British government. Then I had a phase working in private sector. And then finally, we're going to talk a little bit about Mantis. So as we've mentioned, my PhD was actually in forestry or how to measure carbon in trees, essentially. So I guess the first thing to say is that I didn't have any NLP training when I left university or when I left my PhD. So everything I learned about NLP basically is something I picked up through working in industry. And that's for positive and negative. I'll get to that as I move on. So first thing I'm going to talk about really is this time I spent working for the British government. So you can imagine that when I left academia, having been a PhD, having done a PhD, having spent a year as a researcher, and I started interviewing with companies and with startups in London mostly, no one wanted to offer me a job because they looked at my CV and they said, well, this guy doesn't know anything about data science and he doesn't know anything about natural language processing. And they were kind of more or less right. But very luckily at that time, the British government were recruiting data scientists in quite large numbers. And I got recruited to join the Department for Education. And I stayed there for about a year before moving on to a more central government department, which is called the Government Digital Service, which basically was running the digital transformation of the British government. And I guess the first thing I'd say about working in government, it's generally a great place to work, depending on the government of your particular country. But it's a very interesting place to work because there's lots of very interesting problems to solve. But those interesting problems lie at the heart of lots of other problems. And it can take a long time before you can actually get to doing any AI. You have to deal with lots of other things like, actually, how do we actually develop a culture which allows us to work with AI, and then the digital infrastructure required and the data infrastructure, and actually getting high quality enough data to actually then try and do this AI thing. And actually, the NLP component of all of that can be quite small. And I guess that's a theme running through this whole presentation, is that actually the amount of NLP I do these days is much smaller than I'd like, because I have to do all the other stuff as well. That said, there are lots of natural language processing problems in government. This is one particular problem I worked on, which was for gov.uk, which is the British government's main website. And essentially this problem is a problem that all governments have, and probably many government departments also have. And that is how to organize their information so that it can be easily found by users or citizens searching for information. So in this case, we used a convolutional neural network back in the days when there was no Hugging Face, there were no model zoos, so we had to build our own model. We didn't do any transfer learning, we just built everything from scratch. And it worked quite well, and I think it's still being used. I'd love to go into more detail, but I'm going to fly on to the next part just so I can fit everything in. So after I actually left government because I moved to Spain, and for some reason they wouldn't allow me to work in the British government whilst living in Spain. So I moved to a startup called Juro, which is a legal tech startup. And I worked there as the lead data scientist for about a year and a bit, year and a half, something like that. And this was very interesting because this is the first time I sort of stepped away from government, which had a lot of constraints around what kind of technology you could use. And when at Juro, basically I could do anything, but I also had to do everything. So as well as dealing with natural language processing problems, I had to deal with kind of all the other problems as well. So what we were building essentially is a legal document processing pipeline. So we would allow users to upload contracts, and we would process those contracts. Often they didn't contain text, they were images. So we had to do an image analysis first to auto-rectify the PDFs, almost always PDFs. We'd have to run optical character recognition. Then we would hit some interesting NLP problems, so we could do some text classification for particular components of those contracts. And we could also extract some named entity recognition and some named entities. So actually the NLP component was quite simple, but the problem of actually processing all those documents in large numbers and making that, keeping that latency low so it could actually be used in production was a much bigger problem. And when you start working in small companies like startups, you tend to have to take on a lot more tasks than you would in larger companies. So I also had to learn, okay, how do you build an API? How do you containerize all of your models? How do you manage a Kubernetes cluster? How do you work with cloud services like AWS? And all of that kind of came together. So it was a great learning experience. I learned a lot about how to build production systems. But what I really wanted to be doing was building models, and that sort of component ended up shrinking and shrinking. So we probably only built maybe 2 or 3 models, one for extracting particular elements from the contracts, and then the other one we trained our own named entity recognition model. And those 2 problems, I mean, these are the main 2 problems that you'll see in industry: text classification and named entity recognition. They're still the most popular problems that I come across on a day-to-day basis. During this time, let me go back. So during this time that I've kind of blocked together as private sector, once I'd left Juro, I ended up working as a freelance data scientist out of Chile. In fact, I was living in Santiago for some of this time, but I was also in Spain and the UK. And working freelance is great because it gives you quite a lot of flexibility. And you also get you get a lot of variability. So I worked probably for about 5 or 6 clients over those couple of years, and you get to work with different people's problems, and that's good, very interesting. The downside is that you're kind of almost always starting from the beginning, so you rarely get to work on very mature projects. Almost always the projects I worked on were at the very early stages. So I feel like I got very good at starting projects, but not necessarily seeing them through to a nice sort of stage of completion. One of the clients I worked with mostly was the Wellcome Trust. The Wellcome Trust is one of the world's biggest funders of biomedical research, and they have a very interesting set of problems with respect to natural language processing, which is essentially they have something like 160,000 grant applications, normally from scientists who are saying, "Oh, please, please fund my research to research snake bites or malaria or whatever medical area it might be." And they had some issues with how to basically deal with all that information, but also understand the reach of the organization. And this is another problem you see a lot in the industry, is an organization, especially for grant giving organizations, they give money to charities and NGOs, those kind of other organizations, and they want to understand what happens to their money and where it's going. So the particular problem for them was to look into what they call policy documents, which are basically documents published by governments, whether they're national governments or by the United Nations or the European Union, and also international bodies like the World Health Organization, amongst others. And they wanted to know when the research they had funded was appearing in these policy documents. So again, this was another process of building a pipeline to process those documents. We had a scraper which would download thousands of documents every time. We'd pass them through this pipeline to extract the text, to run our models on them. And one of the most important components was finding references to the academic papers which were published based on money that came from the Wellcome Trust. And for that, these policy documents aren't structured like academic papers, so it's very hard to find bibliographic references in them. So we built a neural network to do that. It was a recursive neural network that we copied essentially from another publication we found, which was dealing with papers about the history of Venice, I think, or books about the history of Venice. So we did transfer learning. We took that data, we augmented it with some of our own data, trained our own model, and then we deployed it into production in part of this pipeline, which helped the Wellcome Trust understand, okay, where is our money going? So moving on, that's a quick flavor. I've sort of dedicated half of my talk to kind of what went before Mantis and half of it to what's kind of happening from after Mantis. So in about 2021, in about March 2021, a colleague of mine who I'd been working with at the Wellcome Trust, we decided to start our own company called Mantis NLP. As you can guess, it deals with natural language processing. And essentially, Mantis NLP is a remote-first startup. We have currently just 3 employees and a couple of subcontractors. And we very specifically work on natural language processing problems, whatever they happen to be, but usually they're around text classification, name density recognition, and semantic similarity. That's the sort of main problem we deal with, the sort of specialist problem we deal with, because there's a lot of people dealing with the other 2. So this was something that I started myself with my colleague Nick, and we've been going since 2021. And we kind of have a fairly clear idea of what kind of company we wanted to build. So we focused on these kind of 4 values, which are the use and the sort of furthering of open source software. So we write open source software whenever we can. It was obviously, artificial intelligence and natural language processing relies on open source technology, so we want to contribute to that. We think quite carefully about ethics. So there are some sectors where we don't do projects, defense being one of them, marketing. We think quite carefully about the kind of work we want to do. As far as reproducibility is concerned, this is something that scientists think a lot about, but actually in industry, not everyone thinks a lot about. So we've sort of brought a lot of our kind of learnings about reproducibility from academia to industry, and we work very hard to make sure all of our results are reproducible. And there's very strong commercial reasons why you might want to do that, aside from it being good science. And the final thing is that we try, or we aspire to being responsible in the way we use resources, which isn't always easy when everybody wants you to deploy very, very large models. But I'll get to that. So couple of examples of the projects we're working on. So the longest term project that we've had to date, which we've had right from the beginning, is basically building a chatbot for training doctors. Except it's not a chatbot that you would use, from your phone or in a sort of normal chatbot scenario. This is a virtual reality chatbot. So you put on a headset, you go into a scenario, and you'll be presented with a patient in front of you. And you need to as the doctor, you need to work out what's wrong with the patient and make a diagnosis. And so this system is for training doctors, but also evaluating them. So at the end of the process, the doctor gets a score on how well they've done. And prior to us working with this client, they used the controller. So it's based on like a PlayStation controller. They would go, the user would go in, and then they would choose which responses to say for the patient. And now we've basically built we've used a speech to text service and built a couple of models which now allow us to interact with voice. So you can go into the room and speak normally in English for now, just English for now, and have a real life conversation with the patient, and then you'll kind of get the same score as before. So very interesting project, but I haven't got so much time to talk about it, so I'm going to move straight on. The second project that we've done a lot of work on is back with the Wellcome Trust. So very luckily, after we started the company, they took us on to work with them on a couple of projects. And one of the projects we've worked with them on is helping them to classify their grants. So these grants and the grant applications that I talked about, if you're a researcher, you put in an application to the grant and they give you money. Well, they have 160,000 odd grants, and they didn't have a good system of kind of dealing with which grants relate to kind of which subject area. So we basically built a classifier to classify these grants. It's a multi-label classification system. And we use a system of labels, or it's an ontology called the MESH system, which is the medical subject header system with about 20,000 tags. And we built a model which basically applies these tags to the grants from Wellcome. And this took quite a long time. We trained our own BERT-based model since Hugging Face and Transformers had sort of arrived on the scene, and we were hitting about a 65% accuracy, which doesn't sound very good, but actually when you look at the sort of state of the art for that area, it's about 71%. So for this large, very large, extreme multi-label classification problem, 65% actually is not too bad. I'm going to move on because I'll come back to this project in just 1 second, and my time is ticking away. So my last 5 minutes, I'm going to talk briefly about what's happening in the industry and things that I guess we all kind of need to be aware of. And you could really just subtitle this, how large language models have changed everything, because really in the last 12 months, maybe 18 months, things have changed a lot. And this tweet kind of says it all. So that previous project, which I just talked about, we spent about 2 years working on that. And in the end, we got to, I think I said 65 in the last slide, but actually the F1 score we would get was 65% accuracy, but F1 of 63%. So, we trained a model. We trained a model for 4 days. We had quite a good budget. I think we spent about 10,000 British pounds to train this model over the multiple runs where we trained it. And then GPT-3 came out. And we thought, well, okay, let's try GPT-3. Let's see how GPT-3 performs. And it turns out that in pretty quickly, with just 5 examples, GPT-3 scored 61%. So, you spend £10,000 in 2 years working on a model, and then all of a sudden there's an API you can use which does almost as well for, in almost no time at all. So that's kind of a very brief summary of what's happening in the industry. You kind of have this situation with these large language models where I always think about them as a wedge. So you kind of have the models we've got right now, like GPT-3, and there are some bigger ones that have come out since GPT-3. And you have a lot of organizations like Google, Facebook, OpenAI, and many others building ever bigger models, which perform incredibly, but they have many billions of parameters. So I think GPT-3 was 170 billion. There's some models by NVIDIA now, which have over 500 billion parameters. So huge models, millions of dollars to train. And then on the other end of this scale, you've got these kind of smaller models like BERT. And, previously we would have said BERT is a huge model. When I started in NLP, BERT would have been enormous, but now it's a small model. And these are the models kind of which we use routinely in production. And that's because they're small-ish, they're quick, they do pretty well. But on the other side of the spectrum, we have these large language models, which perform amazingly, but they're expensive, they're quite slow, they can be quite slow, they're often proprietary, and they're very hard to manage in that it's difficult to deploy them. Some of them are so big that you need to invest in either your own hardware or pay for lots of cloud infrastructure in order to run those models, and it's difficult. So what I see happening right now in the industry is there's kind of a move to take the benefits of this side of the wedge and kind of push it down to the other side of the wedge. So that we can utilize the benefits of these super large models like GPT-3, but in much smaller models like BERT, so that they can actually be deployed into production systems without all the problems that we have at this end of the wedge. And there's a couple of ways we might do that. One of the ways that we're working on doing that is to use the larger models to annotate data for us, which is much cheaper actually than asking people to annotate data. And then we use those that annotated data to train smaller models, which are more specific to our problem. Because of course, GPT-3, one of the reasons it's so big, one of the reasons all of these models are so big is because they have huge weights matrices, which basically distill everything on the internet. And we're not interested in everything on the internet for most of our problems, like this medical chatbot, for instance. We have a very specific problem. The other option we can use is distillation to try and distill down very specific, targeted information into those models. But I'm running out of time, so I'm going to swift on to my next and sort of final slide. And this is the other big trend that's sort of happening in industry, and this is the arrival of Hugging Face and their Hugging Face hub. So I took this snapshot a couple of minutes ago. So currently there are 109,000 models which you can download and use from Hugging Face. So previously, as I told you, when I worked in government, we trained our own models. Now we don't really train our own models. Now we download, we go straight to Hugging Face. We find a model that has the right license. We find a model that's specific to our problem, and we download that model, and we start all our projects with a model from Hugging Face. And if we then we find the model's not performing well enough, then we annotate data, possibly with GPT-3 or however, and then we train our model. We use transfer learning to basically train those models and fine tune them to our specific use case. But almost all projects now start with Hugging Face. Oh, that's my time. So I will send these slides around. Hopefully that was interesting, but there's a few links that I'll include which will give you more detail into what I was talking about.
Thank you very much, Matt. Nice having you here today. Muchas gracias, Matt. Para quienes luego quieran hacer preguntas, recuerden que tenemos activo Slido y hay algunas preguntas ahí, así que pueden votar si es que quieren que alguna de esas preguntas suban, o pueden agregar preguntas nuevas. Vamos a darle paso ahora a nuestro segundo presentador y vamos a dejar la sesión de preguntas para el final de la sesión.